Since this is such an important concept, even though this next slide doesn't have any really new information, I'd like to review what we've just said. So the addition of integers. Integers, remember, are the sets of numbers that include all the counting numbers. So let's remember what that looks like. That means 1. When I count, it's natural for me to say 1, 2, 3. And then we know that these dots or ellipses mean they go on forever. So we know that integers are our counting numbers. And then their opposites, which we could write out the other way, going down, and then dot, dot, dot. And then also they include 0. And the only reason we separate out 0 is because it doesn't have an opposite. 0 stands alone as neither negative or positive, so it doesn't have an opposite. So we have to say it's the counting numbers, their opposites, and 0 make up integers. So opposites are numbers that can be written with the same digits and opposite signs. So again, 3 and its little evil twin are 3 and negative 3, 2 and negative 2. Everybody has a partner, 1 and negative 1, except for 0. 0 does not have a negative and a positive. That's why it is not considered an opposite. It's a very unique number. And the opposites always make 0. So to add integers as illustrated on a number line, we always begin at 0, and we move left or right depending on the sign. Remember, negative is always left, and positive is always right. So we go in the order of the signs. So if we see positive 8 plus negative 5, we just go positive 8 and then back 5. And we end up at 3 down here. Okay? So the sum is positive 3 or 3. And we don't have to write the plus sign. When we have a positive number, it's assumed. It's much faster to be able to say 1, 2, 3 than to have to say positive 1, positive 2, positive 3. That's why they're just assumed to be positive until we say they're negative. So to add sign numbers, if the signs are the same, the answer is going to have the same sign. That's another way to look at it. 2 negatives combined together down here. We'll point at those, negative 5 and negative 3. The answer will be negative 8. Positive 5 and positive 8. I'm sorry, if those were both positives, that's a bad example. Because if signs are the same, they're going to keep their same sign. And then they showed an example that didn't show that. Sorry about that. So the 2 negatives make a bigger negative, and 2 positives make a bigger positive. But then they showed a mixed one below. So if the signs are different, you find the difference or subtract the 2 numbers and keep the sign of the greater distance from 0 on the number line. So in other words, the bigger one wins. So the sign of the bigger number wins. Since the 8 is positive and the negative 5 is the negative, 8 is bigger. We know the answer is positive. The difference between 8 and 5 is 3. So we know that it's 3, and we know it's positive 3 because the 8 was positive. Here again, a little more practice just because this is such an important concept. Number 1 says that negative 2 plus negative 7 is going to be something. Well, there are several ways we can look at this. We know that 2 negatives make a bigger negative, so we have a negative 2 and a 7. We add them together, and we should get negative 9. We could also see that we don't need the positive sign in there. We have 2 negatives. That's another way to look at it. On number 2, we have a lot of extra things in there. We have parentheses that are not really doing anything because there's no multiplication. And we have the concept that we talked about where minus a negative is plus. So if we wanted to rewrite this, we could just simplify it to negative 3 plus 6. Or then we could say, what if we put the positive 6 and the negative 3? Oh, then it becomes very obvious, right? Not so obvious, negative 3 plus 6, but 6 minus 3 should make us pretty comfortable. And again, even though we're seeing all these negative signs, the answer is positive. Because remember, if minus a negative becomes plus, then the bigger number is 6 and it's plus, so therefore the answer is going to be positive. And on a number line, we would start at 0, we would go down 3, and then we would say the opposite of negative 6 is positive 6, so we'd go up 3, and up 6, and that would take us to 3 on the number line. So multiple ways to look at these. Number 3 says -9 minus -5, or -9 and the opposite of -5. Well, the opposite of -5 is +5, so we could rewrite this as -9 plus 5. And in this case, we see that the bigger number is negative, so we know the sign is negative, and we just need the difference between the two numbers then. So if I have -4 and I only come up 5, I only get to if we have -9 on our number line, we're way down here at -9, and we only come back 5 places, we end up at -4. That's why -9 plus 5 is -4. Number 4, we have -4 and -8, and we're adding them together. So when we add two negatives together, we get a bigger negative, or when we look at the signs, we know that this sign is useless because numbers only get one sign, and the negative wins. So if we have -4 and -8, I borrowed 4, I borrowed 8 more, I owe 12. Okay? Number 5, at 6 a.m. the temperature is 4 degrees. By noon the temperature has risen 10 degrees. How many degrees has the temperature risen? Now word problems tend to make us a little uncomfortable because we start seeing numbers that we don't need and things that are going on that we're not even sure why they're there. But we need to look carefully because if you've ever read a mystery story, there's an element called a red herring where there's something that might be distracting you. Now, word problems, they're not trying to intentionally fool you, although some students feel like they are. But there'll be numbers in the problem that are not relevant. And those are what I think of as like red herrings in a mystery. They're kind of there to distract you from the real point. Now, we know the lesson is about negative numbers and combining numbers. So it's not a lesson about time. So I'm thinking that it doesn't matter that it's 6 a.m. and it doesn't matter that it's noon. But what matters is this rising and falling of the temperature, because that's the model we were looking at. So if the temperature was at -4, I would make a number line maybe with a -4. And then I would go, well, by noon, and I remember that noon is irrelevant, but the temperature has risen to 10 degrees. Oh my. So it didn't rise 10 degrees. This is a different situation than we've had. It's got to get up to 10 degrees. So I'm going to put something here at 10 degrees, and I'm going to say, well, how would I model this problem? If I did it on a number line, I know that the answer is how far it is to 10. Well, we know that if we put 0 in, it'll be easier because it's going to take me 4 to get up to 0 and 10 more to get to 10. So together, it had to go up 14 degrees. So I'm hoping that that model might help you. And I think it's very helpful to draw a word problem when you're not sure, because you might not even be sure what the equation is. Because you've got a -4 in there, but now it went up to 10 degrees. Do I add? Do I subtract? What's going on? So sometimes modeling this is the best way to see that really you just went up 4 and then you went up 10 more, all between 6 a.m. and noon, and the time is not the issue in this problem. Okay, so it rose 14 degrees altogether. 4 to get to 0 and 10 to get to 10. Now on number 6, we have the situation that at 6 a.m. the temperature was at -9 degrees. So let's put that in, -9. And then at noon, the temperature had risen to -1 degree. So it didn't even get up to 0. It's still even below 0. But somehow it's gone from -9 to -1. And it doesn't say how many degrees it rose. It says that it got to a certain degree. So it went from -9 up to -1. All we need to know on a number line is how far it is between -9 and -1. So there's a couple of ways you could write your equation, but you could just say if I'm going from -9 up to -1, I'm going up 8, and that would be that the degrees have gone up. It's gone up 8 degrees. So again, these are very easy to model. And you throw out your little red herrings. 6 a.m. doesn't matter. Noon doesn't matter. All that matters is where we started and where we ended and how long it took, what the difference was. And the difference, if we had to write an equation, technically we would say that it would be -9 -9 plus something is going to get me up to -1. And see, again, it's this missing number here that we're looking for. So although that's in algebra, they would teach you a different way to do this. What you can do on a number line is just say, how many spaces am I going up to get to -1? And that's how you would get your 8 degrees. So other than going into an entire algebra lesson, which I'm not thinking is the intent of this particular lesson, you can use your number line to see how that would be 8 degrees.